Hello everyone, this is DSA in the world. Today we are going to solve the 19th question of our DSA sheet, and the question is jump game. So now let's look at the problem statement. You are given an integer array nums. You are initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index or false otherwise. Now let's look at the example. So first of all, we have array or vector, right? Which is 2, 3, 1, 1, 4. So what does 2 represent over there? 2 represent like either you can you can take at max 2 jump from this index. Like first can be this and second one can be this. Either like this is the maximum value, but you can also like take 1 jump or either 2 jump. Same goes for 3. Like for 3, you can what you can do, you either you can go for 1 jump, 2 jump, but you need to remember guys one thing. At max, you can take 3 jump, right? This is what is meant by the line over there. Like each element in the array represents your maximum jump length at that position, right? And what we need to do, like since this is the array, what we'll do, we'll jump one step from index 0 to 1, and then we'll take 3 steps. Like it will be something like this: 2, 3, 1, 1, 4. So first of all, what we'll do, we'll take 1 jump. Then after this, what we'll do, we'll take 3 jump, 1, 2, and 3, right? These 3 jumps and this 1 jump. So we just need to return 3. So now let's look at the second example also. Over there, we have 3, 2, 1, 0, 4, right? So let's try to jump like 3, 1, 2, 3. So after this, like we can't like take any jump since we encountered 0, right? So let's try a different approach. Like let's try with the 2 jumps, right? After this, since you are at 1, you just need to take 1 more jump, right? But there is no like, since you encountered 0 again, so there is no jump over there, right? Right. So let's try the third one also, which is by taking 1 jump. So when we are at this position, now let's try to take two jump initially. 1, 2. So again, we encountered 0, so there is no such way. So now let's try a different one. Like after taking 1 jump, what we'll do, we'll take 1 jump from this 2, because at max we can have 2 jumps. So again, we'll have 1. So again, we encountered 0 over there. So there is no possible way from which you can reach the last index, right? You will always arrive at index 3 no matter what. Its maximum jump length is 0, which makes it impossible to reach the last index, right? I hope the problem statement is clear to all of you guys. Now let's jump into the approach and try to figure out like how we are going to solve this question, right? This one is the approach. So let's take this example: 2, 3, 1, 1, 4. This is our example 1, and this is our example 2, which is 3, 2, 1, 0, 4. 3, 2, 1, 0, 4. So whenever there is like, just try to observe the pattern from the first example. When there is no 0 in the entire array, what does it mean? This means we can reach the last index, right? The problem arises when we encountered 0. Then there, from there we can either like go to the, like there might be two choices. Like either we can reach the last index, or like there might not be some case like through which like we can reach the last index, right? Like either we can reach last index, either there is no such condition. So we need to take care for this case, like whenever we find 0 in array. So what we'll be doing, we'll follow greedy approach. Simply like which will we just need to traverse the array only once, and we'll try to figure this thing out, like how we are going to solve this, right? So now let's just take a different example so that this approach is clear to all of you guys. Now let's take this example, which is 1, 1, 2, 5, 2, 1, 0, 0, 1, and 3. So initially what we'll be doing, let's say this is our target, like this is our initial target, right? So what we'll be doing, we'll try to traverse the array in a backward direction, right? Let me just make this thing clear to all of you guys, like how we are going to traverse in a backward direction. Initially, we'll be having our target. So from there, like when we are at this element, we can directly see we can make one jump so that we can reach the last index, right? So after this, what we'll be doing, we'll directly shift our target to this value. This is our target. So now now our pointer will be at this position. So there is no way that we can reach this index, right? So we'll again increment our, like, what do I mean by incrementing? Like, we'll try to increment our pointer in a backward direction, like in this direction, from right to left. So again, like our pointer will be pointing to 0. So there is no such way, like, in which we can reach our target, right? So will increment our pointer. So is there a way? No, there is no such way, like, because we encountered 0 again. So we'll increment our pointer. So is there a way such that, like, we can reach the our destination, like our target? 1, 2. There is no such way, right? Because we again encountered 0, so there is no such path through which we can reach our target. Remember, guys, we'll directly, like, try to modify our target when we traverse through the array. Like, this thing will be clear to all of you guys, like, as soon as we, like, complete the diagram of this example, right? So now we'll increment our pointer. So when we are at 5, when we make 5 jumps, 1, 2, 3, 4, 5. As we can see, like, we directly reach our target, right? So what we'll be doing? So at this position, we again reach our target by 5th position. So we'll directly shift our target to 5th position, and this now this will be our target, right? So our pointer will be at this position, right? So either we can go for one jump, either we can go for two jumps, either we can see directly, we can move it over there, like, by making one jump, right? So we'll again modify our target. This will be our target now, and our pointer will be something over there. Yeah, we can directly reach by making one jump, and we again modify our target. Then we can directly reach that. So when we traverse over our entire matrix, sorry, array, we figured this thing out, like, we can have jumps something like this. Let's say when we are, like, one, one jump, and then one more jump, then one more jump, 2, 1, 0, 0, 1, 3. Then 5 jumps, 1, 2, 3, 4, 5, right? Yeah, 5 jumps. These 5 jumps, 1, 1, 1, and again we'll have one jump, and we reach our last index. So what we'll be doing, we'll just modify our target to the, like, destination, and in the backward direction, we try to find out whether we can, like, if, like, just try to analyze this, right? If we can reach over there by making one move, right? So let's say if this is our last index. So if we can reach over this last index, this means we can directly reach over our last index, which is the actual index. This is our actual last index, right? This is our new last index. So if we reach our new last index, then we can directly reach our actual last index. So we'll try to make some changes in the new last index. We'll try to, like, shift our last index. So if we can reach 5, like, so this means directly we can reach over there, right? I hope this approach is clear to all of you guys. We are just making a new last index, which will, like, ultimately be saying like if we can reach our new last index, then it will directly lead us to like be pointing to our actual last index, right? This is the main approach which we'll be trying to follow, right? Let's say if instead of 5 we have something like 3, like instead of 5 we have 3, so there is no possible way through which we can uh, reach the last index. In this question we just need to return true or false, like either we can reach our last index or not. There is no such question like you just need to return the minimum number of steps in which you can reach the last index. This might be some different question, right? In this question, we just need to return true or false. We don't need to care about the number of steps which will take to reach the last index, right? I hope this approach is clear to all guys. We actually modify our new last index and will this will directly lead to actual last index, right? We just need to find out if you can reach the final position from this index, right? This is our final position, like new final position, right? This target. This means like if we are at this index, like this will be the condition, right? Let me just write this thing for you. If index plus nums of index is greater than final position, right? If this thing holds true, then we need to modify our final position, right? This will be index, right? This is the condition we need to check for modifying our new last index, right? For modifying, you can say this thing like final position or the new last index, either, yeah, it totally depends upon you, right? Now let's try to code this thing up so that you guys have a better understanding. So here we are, let's say int final position, right? This will be initially pointing to the last index, right? So start with the second last index. So we our pointer will be something pointing to int index equals num slot size minus 2, like the last second index, and id x greater than equal to 0 since we traverse in the backward direction, and index minus minus, right? So after this, we need to check this condition if index plus, so over there we have index plus nums of index is greater than equal to our final position, then we need to update our final position to index, right? I hope this thing is clear to all of you guys, like why we are making this. Like if this thing is not clear to you, just do a drag and by yourself on some different example, right? So at the end of this, we'll directly return final position equal 0, right? If we reach the first index, then we can make the jump possible, right? So now let's try to run this code. Yeah, this sounds perfectly fine. Now let's submit this. Yeah, this was submitted. Now let's discuss the time and space complexity for this problem. Since we are just iterating over array of vector, then its time complexity would be big of n, and space complexity would be big of 1, since we are not using any extra space. I hope this greedy approach is clear to all of you guys. Just do a dragon by yourself with the help of pen and paper, and this thing will be clear to all of you guys, right? Thank you so much for viewing the video till the end. Please like, share, subscribe, and comment if you have any doubt. Thank you so much.